I'm delighted to introduce our next speaker, James Manyika. James is Senior Vice President for Technology and Society at Google. He focuses on areas ranging from AI, computing infrastructure, to the future of work, the digital economy, and sustainability that have potential for broad impact on society. He is Senior Partner Emeritus of McKinsey & Company and is Chair and Director Emeritus of the McKinsey Global Institute. He was appointed by President Obama as Vice Chair of the Global Development Council at the White House and by Commerce Secretaries to the Digital Economy Board and the National Innovation Board. He is Vice Chair of the National AI Committee, which advises the US President and the National AI Initiative Office. A Rhodes Scholar, he has a Doctorate of Philosophy, Master of Science, Master of Arts from Oxford in AI and Robotics, Mathematics, and Computer Science. A Bachelor of Science from the University of Zimbabwe. James is joined by Alexandr Wang, CEO and founder at Scale. Alex, over to you.
James, I'm so excited for this conversation. Thanks for coming by.
Well, thank you so much for having me. I've been wanting to do this for such a long time, and I'm just thrilled to be here.
I think we're gonna have an incredible conversation, and so let's dive right in. You know, it's really inspiring to be able to chat with somebody who not only obviously understands the technical fundamentals of artificial intelligence and much of the history, frankly, so deeply, while also being so tuned in and thoughtful about the policy components and its implications on society. And so I think this will be a really amazing conversation.
Well, I'm actually just thrilled because you've actually built a company that actually does this, which is amazing.
Well, a lot of mutual admiration. So I'd love to just start by talking about your background. You know, you spent a lot of time studying both sort of hard sciences and science as well as humanities in your studies both in Zimbabwe as well as at Oxford. And so I'd love to hear a little bit about that. How did you think about what to study? How did you guide your sort of interests early on?
Well, it's interesting for me because I grew up wanting to be an astronaut, actually.
Oh, wow.
It's kind of what I grew up wanting to do. And that wasn't going to happen for lots of reasons. But so my undergraduate degree was actually in electrical engineering. And then when I went to grad school, I did a combination of mathematics and computer science. I did a double master's thing. And then I did my PhD in AI and robotics. So the humanities were really kind of moonlighting. I just took extra courses and classes in other things. But actually, my core studies were all math, computer science, and engineering. But I was always interested in, I think part of the reason I was interested in the humanities was I've always seen technology as having an impact in society more broadly.
Yep.
And that has always made me want to think about, okay, so how do we put technology into society to have the most beneficial impact? So that's what in some ways drew me to wanting to think about the impact of technology on the economy, on ethics, and all these kind of larger societal questions.
Yep. And obviously we'll snake through all those topics here in a moment. And then you found your way through. You did some work at JPL. You did some more research at MIT. You worked at McKinsey for a bit, and then eventually found your way to Google. Maybe walk me through just at a high level how each of these twists and turns. What were some of the things that excited you about each move, and what continues to sort of inspire you?
I think the work at JPL, that was me still trying to be an astronaut, actually, except that I wasn't going to be an astronaut. So it turned out that a lot of the research that I was doing at Oxford in machine perception, machine learning, was actually very applicable to the Mars rover vehicle projects that were going on at JPL. So I was actually visiting scientists there in the man-machine systems group, because we were trying to build these systems that simultaneously kind of learn their environment through machine learning and other techniques, and then try to build maps of where they are so they can actually plan actions within that environment. It's the kind of thing you need to do if you're going to send a probe to some far-off place where you can't always manage it remotely. So that's what was interesting to me about that work. And then I went to McKinsey afterwards, and that was mostly driven by the desire to say, well, rather than work in these very narrow but very deep areas, how do I think about the impact of technology more broadly in the world? So that was kind of interesting to, in some ways, discover business, discover the economy, discover these larger spaces that technology has to play in. And then at Google, the story at Google is actually quite fascinating. So, our mutual friend, Eric, actually made me an offer to join Google back in 2001.
Oh, wow. Very early days.
Oh, yeah. And it's quite funny. So we ended up having this kind of annual ritual conversation about when are you coming, when are you coming? And then finally, Sundar convinced me. And part of what was interesting about when Sundar finally and others finally convinced me was just a desire to go back to work more deeply with technology and what the cutting edge of AI was actually doing at that time. So it was a chance for me to go work with people that I've known for a very long time, people like Jeff Dean, Demis Hassabis, who I've been friends with for a long time. In fact, I've been a research fellow at DeepMind for quite a long time, even before I joined Google. So this was a chance just to go work with my friends, quite frankly, and see what they were doing and try and help them.
Yeah, and artificial intelligence, even in just this short period, has just entirely blossomed as a field.
Oh, it's spectacular. So one of the fun things I had the fun opportunity to do 2 years ago was the American Academy of Arts and Sciences asked me to put together and guest edit this whole volume of Dædalus. That's the volume of the journal of the American Academy of Arts and Sciences. The idea was to devote the whole thing to AI and society. I went back and looked at the history. The last time that the Academy had devoted a whole volume of Dædalus to AI was in 1988. And if you went back and actually looked at it, Alex, you'd have fun. So the essays in that volume, everybody's arguing with each other about why are we wasting time on AI? It hasn't done anything. In fact, there's a wonderful essay in that old volume by Hilary Putnam from Harvard. The essay is actually entitled "Much to Do About Nothing." They're saying, why are we wasting time? This is a waste of time. So it's a very different time.
Yeah, and obviously compute and sort of, the smartest people working on this problem have just caused these massive advancements. And now I think, a lot of what AI is accomplishing is sort of indistinguishable from magic. It's sort of, it's just absolutely amazing.
Oh, no, it's been phenomenal. I mean, I think in many respects, and you know this because you've built a whole company doing this. I mean, I think the combination of, availability of data has made a big difference. I think improvements in the techniques we use for AI, finally realizing that, in fact, focusing on machine learning as opposed to just symbolic reasoning, which was what the old AI, pioneers were trying to do, is a much better way to do it. And then also the innovations of compute infrastructure, when people like Jeff Dean and others finally realized that, in fact, there's a different way to do these vector calculations. And in fact, GPUs are actually pretty good at it. And then they finally ended up inventing TPUs. So those innovations have made an enormous difference, as you well know.
Yeah, it's kind of hilarious, actually. The original AlexNet, which was sort of the first maybe modern deep learning approach, was trained fully on CPUs. And obviously, at the time, there's no other option, so it sort of makes perfect sense. But now you sort of look back and you're like, wow, that's so quaint.
Yeah, no, it is quaint. And I think the big insight was realizing that when you're doing these massive matrix vector calculations, you don't need the kind of the floating point precision that CPUs typically give you. You can actually do that with fairly crude, techniques. So the accuracy is not as important, but being able to do these massively parallel vector calculations is even more important for both the training and also for the inference. That made a big difference. And so that's why GPUs are useful. That's why TPUs are even better. And it's just been amazing.
Yeah. Well, you began, the Dædalus volume is obviously incredible. And you began it with this quote from Ex Machina, the incredible sci-fi movie about AI. And if I recall, roughly paraphrasing, it was sort of, it was this quote that describes sort of the monumental nature, this moment in human history of sort of the invention of AI. And I think right now we're at this very, as a society, we're really at this precipice when it comes to artificial intelligence. I think it's sort of progressed faster than many of us, especially even people in the field, really expected. And the capabilities are really quite staggering. And there's sort of all these question marks around not only the implications of the current technology on society, but also the near future technologies and where that's going to get to. And so I'd love to just start by maybe hearing you describe how do you think about where we are in AI and the relation of that to sort of how society will manage through these advancements?
Well, I think, as you point out, Alex, it's an extraordinary time. I think if you'd asked me when I was doing my PhD, I would never have imagined that we would be where we are today. It's just been phenomenal. And so the possibilities are amazing. So when I think about where we are, I think about all the amazing problems we can now solve, all the amazing useful things we can now do with these techniques. I mean, you and I were just talking about our mutual friend Demis Hassabis. The fact that his team has now predicted the protein structures of all known proteins, all 201 million of them. That's extraordinary. I mean, that was something that was initially set up as a grand challenge 50 years ago, and Demis and team went from 0 to where they are now in like 18 months. I mean, that's extraordinary. So you look at all these amazing possibilities, what we can now translate, the images we can now understand. It's phenomenal. At the same time, I think because of that progress, AI has always had this aura about it that on the one hand, it'd be the greatest event in human history, I think is what Stuart Russell and others predicted when we get to more general systems. It's always created this sense of fear and foreboding to say, what does it actually mean if we have systems that can actually do these extraordinary things? And I think that's where you start to get these questions about what it means for society. So on the one hand, society will benefit, there's no question. Drug discovery, the life sciences, all these amazing things that will happen. At the same time, there tends to often be two kinds of concerns, maybe a third. One kind of concern has to do often with the whole jobs question. So if we have systems that can do all these things that humans can do, what does that mean for the future of work? So there's a whole set of concerns of that form. Another bucket of concerns tends to be the more, if you like, the what I'll call the ethical questions about, okay, so if we have these systems that are incredibly capable, what should we use them for and what should we not use them for? Should we worry if they fall into the hands of not so good people as opposed to just the good people? So those are a whole bunch of kind of ethical concerns. And then there's always the one that kind of is hanging out there, I think, for everybody who's ever watched Ex Machina or 2001: A Space Odyssey, which is the concern that some have about what if we lose control? That's always the kind of the existential question. So these questions are undoubtedly going to come up whenever you have a powerful technology that now has the potential to do these extraordinary things. And I think those tends to be the societal questions that people grapple with. Now, we have some very immediate ones that are on everybody's mind. So because these systems are still new, they're not perfect yet, people worry about concerns about bias, about toxicity, and all those things. But I think we'll solve those things. I worry more about the use-misuse questions because those are much harder to think through.
Yeah. Well, we'll walk through each of these sorts of topics through the course of the conversation. Let's start this one around jobs. It's a very natural concern, obviously, because as you build sort of these machines and these algorithms that can do things that previously we thought were purely human or sort of like unique to humans, there is this question around displacement and sort of like the economic implications of that. What are your thoughts on that? How do you think about what will happen over the course of, let's say, the next decade as AI technology becomes more and more used?
Well, I think so. There's been an extraordinary number of studies and research, and I've done quite a number of them actually, looking at these questions of what happens to work and jobs and so forth. And I think if you look at most of what I think is the extraordinary research that we've done, but also others at MIT and others have done, at the task level, if you look at the actual tasks that make up jobs, so most people's jobs, your job, my job, is an amalgamation of different tasks. So if you look at each of those tasks, try to understand which of those look like they could be replaced or automatable by machines. if you do that across all the occupations, so we did this, for example, looking at this, something, the Bureau of Labor categorizes something like 850 occupations, and you kind of go through all of them. You come to a few conclusions. One is that the number of actual jobs where the constituent tasks look like they could be easily automated is not that large in the next couple of decades. It's probably maybe 10% of occupations.
Yep.
So that already starts to tell you whether, at least in the next couple of decades, the worry that work will disappear is probably not well-founded. Others have come to similar conclusions, by the way. So our number is 10%. Some have numbers as low as 6%. Some have numbers as high as even 20%. That's in the near term. But what you do find with this task level analysis is that many more jobs will change than get automated. That comes from realizing that something like 60% of all occupations have something like about a third of their constituent tasks that can be automated. So that starts to tell you that there's more complementing and as opposed to replacement. That's in the near term. So if you look at the next decade or two, which is what you asked about, I would not worry about the jobless future question in that time frame because it doesn't look like that's what will happen. But I would worry about a few things. I would worry about, do people have the right skills to work alongside machines? Are we helping people train and build new skills to adapt to this new workforce? That's why the focus on questions like reskilling and adaptation and on-the-job learning are really, really important. However, if you then look much further out, then you start to have big questions because then at that point, it's not inconceivable that many of the systems, many of the activities that people do could be done by machines. Now, that also depends on how far we've actually succeeded in building more general systems and more capable systems. Then we have to start thinking about, so what happens then? And I think that's where the speculations become quite interesting. And I think it's a classic kind of a Star Trek future question. So what do people do in a Star Trek economy? I don't know. I think they go explore the universe and they create new kinds of goods. And maybe we come to value human labor for its own sake, not because that's the only way to do it. So you can imagine different kind of economic systems emerging in that world. But we would still have to worry about, okay, so how do people derive an income? And that becomes a really hard question because throughout the course of history, the majority of people, the vast majority of people, even today, they derive their livelihood from their work, from their labor activities. So if you take that away, what happens then? That's a big question. I don't know how you think about it, but that becomes a really, really big question. And I think we should think about it well in advance of when that happens, even though I think that's, decades or if not more than 100 years away.
Well, I think you brought up some great points there that I agree with a lot. One of the ideas that we've spoken a lot about is sort of the idea of the Turing trap, which is done by again, our mutual friend Eric Brynjolfsson.
Brilliant, yeah.
And the core idea, obviously, is that because of how we've talked about the Turing test all this time, we often think about AI as this replacement for human work. But just as you just described, it's more of a augmentative technology. The appropriate way to think about from an economic perspective is actually how can you sort of combine and do human machine teaming to create totally new business models and economic models and totally new technologies that just couldn't have existed before.
Right.
And I think we're going to see a lot of that even with all the creative pursuits with DALL-E and Midjourney and these new technologies. I think the art fundamentally is changing. It's the art of even a year ago is not the art of next year. And it's true, the art of a year ago may have been quote unquote automated by AI, but humans are infinitely creative and are going to find ways to utilize this new technology to create just spectacular new forms of art.
No, I think you're exactly right, Alex, because you're already starting to see when people play with Imagen and any of these image generation technologies like DALL-E and so forth, even for creative tasks, they become almost assistive technologies. So we see this a lot with, even on the systems that Google's developing where people, start to play with them. Often they're using them almost as assistive technologies. So I think this focus on how can we build very helpful technologies? I mean, you mentioned the Turing trap. It's a fascinating, actually, argument that Eric Brynjolfsson poses, right? Which is often as technologists and research scientists or researchers, we often like to use these human benchmarks. So say, okay, so how good is our machine vision? How compared to humans? How good is natural language processing compared to humans? And I think the more we create these kind of human benchmarks, which is a sensible thing to do, a logical thing to do from an engineering research standpoint, it gives you something to aim for. It also increases the odds that we're building substitutive technologies as opposed to complementing technologies, as opposed to if we said, well, why don't we build a system that can see around corners? Human beings can't see around corners. What if we build a system that can see beyond the spectrum that humans can understand and see, or the audio frequencies that humans can understand and hear? Then that becomes interesting. Then you're more likely to build complementary technology. So I think there's something about even the goals we set for ourselves, for the kind of systems we want to build, that can actually help a lot. But I actually would hope that we build more assistive technologies that are helpful to people, that help people do their everyday tasks, and quite frankly, complement them by doing things that they can't do. That's why I love, for example, what Demis is doing with even systems like AlphaFold. Humans have not been able to solve that problem. It's actually helpful that AlphaFold algorithm is actually helping us understand protein structures, which is amazing.
Yeah, exactly. And then the other point that you touched on, which I think is absolutely critical, is this component of reskilling, which is, if there's any policymakers who are sort of like listening to this right now, I would drive this point home, bar none, because if you think about it, let's take the history of America, for example. Right. There have been a number of moments where we've had to do major reskilling. The most recent probably is post World War II.
Yeah.
And there was a huge, this sort of massive push to not only create a lot of jobs in America, but also to get people to college, become educated, and drive sort of this huge reskilling of the American population. And obviously versions of that have occurred in many of the countries around the world. And I think this upcoming sort of challenge is no different, in that I think it's a tractable problem as long as we're clear about what are the skills that will persist and are going to continue to become extremely relevant, and how do we help ensure that as a workforce or as a population we're well outfitted for the upcoming technology wave.
No, I think, Alex, you're exactly right. One of the things that was interesting, by the way, one of the first commissions that was looking at these questions of technology and automation and jobs and work was actually in 1964. It was initiated by President Lyndon Johnson. This is because if you know, in the history of AI and automation, there was a big moment of excitement after the famous 1956 Dartmouth conference that actually coined the term artificial intelligence. And so there was a lot of excitement initially. So President Johnson actually commissioned this task force to look at technology jobs in the economy. This is in the 60s. And they published their report in 1967. One of the conclusions in the report was that technology destroys jobs, but not work, which I think is a very simple but profound statement, right? But if you then look in the details of that report, it emphasized the need for skills, for education, and so forth. So I think we've benefited a lot, the American economy has benefited a lot from the ability of people to build skills, learn on the job, and become better at what they do. But I think the challenge is even greater now in this moment, partly because we're making faster progress on these technologies. And the imperative to actually build the skills that you're talking about is that much greater. So I think the real challenge for all of us collectively is, how do we do this reskilling at scale? Scale AI, right? So how do we do these things at scale is the challenge. And often what I see, because I've been involved in quite a few of these future of work commissions, including the one that the governor here in California asked me to be involved in, is that quite often when you look at the reskilling examples, often they're very small scale.
Yep.
Right, either, we've reskilled 100 people, or even 1,000 people, or even 10,000 people. But the kind of scale of the problem we're talking about here is in the millions of people. How do we get millions of people to adapt and build new skills? So maybe you can come up with, you are scale AI after all. How do we do these things at scale? I think it's one of the biggest challenges that we've got.
100%. And I think one of the key, at least one of the ways that I think about it a lot is, these AI systems, they're intelligence machines, not learning machines.
Oh, that's interesting.
Which is a little, it's funny.
Say more about that. Say more about that.
Yeah, well, I think that they're quite unlike how like a child is a learning machine.
Right.
Children begin knowing almost nothing, but learn at just this incredible rate with very low amounts of input as they sort of like progress through the world. And they sort of learn all these concepts very, very quickly and sort of progress at this incredible rate.
They're great one-shot learners.
Exactly.
Right.
And the nuances, like if you look at the machine learning systems of today, they're closer to intelligence machines. They require this massive amount of effort, massive amounts of data, massive amounts of compute, this sort of Herculean engineering effort to get to pretty incredible levels of intelligence. But the rate of change, they always hit these plateaus, and the rate of change is always quite limited. And even in these, even these systems where you see these great few-shot learners, that's because there's sort of all this embedded intelligence within the system, not because they're truly sort of like learning at the moment. And I think this is my opinion. I think this is one of the great sort of challenges left in the overall field of artificial intelligence. But I think what this means is there's sort of there's always going to be skills in sort of harnessing these intelligence machines with low risk of them sort of learning beyond our own capabilities. But harnessing the intelligence machines, I think there's jobs, so to speak, around machine teaching, of which data annotation and data labeling was maybe the early form of that. And now there's sort of we've done work with some of the large research labs around how to use human feedback to sort of guide the large language models over time. How do you make them less biased or better at summarization or sort of more nuanced in their judgments? And I think that there's going to be a lot of work, millions and millions of jobs around helping to fine-tune and guide and sort of shepherd these intelligence machines to actually do useful things.
Well, it's actually interesting when you think about the progression you just described, Alex. That's actually very insightful because, as you said, there were early rounds of the work that humans did around these intelligent systems, and that work itself will evolve, right? As you say, maybe the next round of it is going to be a whole kind of job categories, activities around fine-tuning systems, for example. And we've seen this, for example, one of the most sophisticated systems that Google researchers come up with is this Palm architecture, where you can now do chain of reasoning and so forth. But the way it's able to do that is that the first time you train this ginormous 540 billion parameter model, it's not very good at that. But then you give it a few prompts, clever prompts given to it by human beings. That is a form of fine-tuning. So we may find that we may have an enormous, or these adjacent activities that are around these large computer systems or machine learning systems where humans can bring their ingenuity and creativity to do those things. I think, as you say, that will probably persist for a very long time around these systems. I also would add that there's one of the key things that's been fascinating to me is to think about the questions of not just even making these systems better, but how do we put out these systems into the world? These are often the questions of socio-technical embedding. How do we do that effectively? And that often probably means evolution to our institutional systems, evolution to how society itself works to adapt and take advantage of these capabilities. And that's all human work, I think.
Right.
So I think it's back to this notion again from the Lyndon Johnson Commission that technology destroys jobs but not work. Question is, how do we adapt to the new forms of work and activities that evolve as these systems become more sophisticated?
I mean, that's a first of all, that line is so great, and it actually just even made me think of, as you were describing that, you think about the advent of professional software, right? Knowing how to use Photoshop is a skill, or knowing how to use video editing technology is a skill. and these are there's jobs associated with them that didn't exist before you had the computer and you had the software.
Right.
And in the same way, you're going to have all these jobs around utilizing the technology and the sort of the software, the tools that become accessible with AI technology.
Yeah, I'll give you a good example. I remember one of the things I learned very early. This is probably about several years ago. I used to lead the McKinsey Global Institute, and we're working with this economist, and one of the Nobel laureate said, one of the things that's often misunderstood is if you look at I think I mentioned earlier that the Bureau of Labor tracks these roughly 800 plus, give or take, occupations. They always have a category called other. So, by job occupations, they talk about electrician, mechanic, and so forth. There's always this other category. And so he said, why don't you go look at the growth rates of all these job categories? And it turned out that over a 10-year period, and this has been consistent since they created these categorizations, the fastest growing job category is other.
Yep.
And that typically reflects these jobs that have just emerged, that didn't exist before. They haven't quite classified them. I remember he then had us go back and look, and I remember we looked at data from 1995. The other category were included jobs we now call web designers. At that time, they were just other, because there's this thing that's growing. Don't know what this activity is. It seems to be growing. So I think we forget that we're always creating these new, interesting activities.
Yep.
And in fact, it's always stayed with me that this other category was actually the fastest growing job category, was other.
Yeah, it's amazing. Well, I wanted to now switch gears to the second concern that you had brought up, because I think it's sort of equally interesting and so important, which is around ethical use of artificial intelligence and sort of maybe the dynamics on a world stage. What happens when there might be some actors who are more willing to use the technology for sort of evil or bad than others. I know this is a topic that you've thought a lot about, and it's actually quite relevant even to the work at Google, because you all have built these incredibly impressive artificial intelligence systems, and you think a lot. You're very thoughtful about how you apply them. And so maybe just to start out with, what's your framework for, given where the technology is right now, how do you think about ethical use and what has to be in place for ethical use?
Yeah, so I think, first of all, it's worth maybe laying out the whole landscape, of at least the way I think about it, of the things in this category of use and misuse. I think, first of all, there's kind of inadvertent misuse. So one of the things, you know this well, which is quite often these systems don't do well when you apply them to kind of an out-of-distribution problem.
Yeah.
It doesn't understand that data distribution, so you apply and apply. So that's a version of misuse where you've trained it for this data distribution, now using it for an out-of-band distribution. It probably won't work as well. And that's an inadvertent misapplication, if you like.
Right.
Maybe not so much misuse as opposed to misapplication. Then you've got misuse where it's been built for within the safety parameters, and then somebody's putting it in a system, in an environment where it's not ready for those safe parameters. Maybe it's an application that was built for a consumer application. Now you're putting it in a health, medical context, and the safeguards aren't quite the same thing. So you have to think about that. Then you've got misuse where somebody is actually deliberately misusing the system, either for criminal purposes or disinformation or to subvert cybersecurity systems. That's the kind of deliberate misuse. So you have to think about all these different categories of use and misuse. And also even questions like, I'll come up with a different ethical question that's not so much a misuse question. And it's now becoming a real question today. So we're now building these incredible conversational systems that are able to have conversations. So a different kind of ethical question is, do you want that system to really sound like a human being?
Right.
You can probably make it sound like a human being, exactly like a human being. Is that a good thing or not? Now, there may be some context in which you actually wanted to do that. Imagine if you're trying to help, I don't know, perhaps an older patient in a bedside manner, you want them to get comfortable, maybe you actually do want that. But then there are other applications where you say, well, actually you don't want that, because it could create the possibility that the person thinks they're talking to a human being when they're not. And then is that appropriate to make the human think they're talking to a human being when they're not? Probably inappropriate. So it's a vast landscape of issues and concerns you have to think about. I think one of the things that most of the, I think, principled research organizations, and I would actually include Google in this regard, have come up with very important and very useful principles. And often what you see in a lot of those principles, so Google has these 7 principles to guide AI use. Often they usually put concerns about harms at the center, which is, how do we make sure these systems aren't harmful and aren't used for harmful purposes?
Right.
And can we restrict use of our systems to not be applied for harmful systems? So centering these issues, questions of harm as best as you can understand them, becomes very important. I think also, insisting that you include, a broader range of experts, not just the computer scientists, but social scientists, ethicists, and philosophers, is also quite important. So at Google, for example, we have a responsible AI team that consists of people that don't have backgrounds like yours and mine, who are ethicists and social scientists and so forth. That's also quite important. I think one of the things that was that I was involved in quite recently, so the National Academies of Engineering, Science, and Medicine, we've had this committee on responsible computing research and its applications. And what you see when we looked at all these questions about use and misuse comes down to how do you involve everybody? How do you involve the affected communities? How do you involve social scientists? And how do you put principles that probably emphasize utility and usefulness of the system, beneficial use, and centers and prioritizes questions of harm? Now, I know one of the questions you raised at the beginning is, this may all be fair and good if you've got an environment, you've got rules and checks and balances and accountability, and people kind of live by this. What if you then suddenly are in a geopolitical situation where you talk about nation states competing with each other? I think that's where you have to try and encourage everybody to understand that it's actually in everybody's interest to ground these systems on these values of ethical consideration, use, because you don't want I'm sure nobody on either side of these systems would want the other side to not be doing this on a principled basis. But that's a conversation we're going to have as a global community. Our other mutual friend, I think, is, Eric Schmidt and Henry Kissinger wrote this book on AI that tries to get at these geopolitical questions about how do we think about these questions. A more complicated area comes to the possible militarization of these systems. So in the Dædalus volume you and I were just talking about earlier, Ash Carter actually writes a very thoughtful essay. Ash Carter used to be the Secretary of Defense. And in that essay, he actually argues forcefully that, in fact, it is always possible to have humans in the loop and in the consideration about how we use these systems. And in fact, having that doesn't necessarily disadvantage you necessarily. So I think the more people understand those kinds of arguments, the more important it becomes. But I hope that we can have a global conversation about these things, because it's in everybody's interest that we're thinking, being very thoughtful about use and misuse of these systems.
Totally. I mean, one thing, there's 2 points that I want to dig into based on what you had just described. The first is kind of this sort of like this element of you sort of pose this question: do you actually want these AI chatbots, let's say, or conversational agents to seem like humans, right? And what are the implications of that? Another topic that we've talked about is it was in relation to sort of like the autocomplete systems at Google that you've built, and sort of like how do these things subtly change human behavior? I'd love to hear you talk a little bit about that, because I think it's so interesting if like how is AI going to change what it means for us to be human,
Yeah, and I think that those are, because one of the questions about what it means to be human, I think in many respects these systems are almost a mirror, providing a mirror for us as people, as humanity, quite frankly, which is, Because if you think about all the ways in which we've thought about what does it mean to be a human, to be an intelligent human, right? It used to be there was a time when we said, well, you're intelligent if you can do math in your head, right? Well, calculators took that away, right? This is good, right? And there was a time when I thought, well, it's intelligent if you can remember facts, if you can remember, recite facts. So over time, a lot of the ways in which you've described what being human means, systems and machine learning systems have become able to do that. There was a time when I said, well, to be human means you can be creative. You can create a piece of art that has emotion in it and that has, clearly, it reflects the suffering you've had as a human being and all these things. But, on blind tests, some systems can actually create those things. So I think in every single case, we're starting to chip away at the historical, perhaps traditional notions that we've used to define what it means to be human. And so the question is, it forces us to think about, okay, so what do we mean by being human? I'll pick another example. We've often said, well, it's important for these, for these systems to be fair. Okay, what does fair mean? In fact, there's a famous paper by some computer scientists who said, well, let's try to figure out what fair means so we can code it into the algorithms. And I think they came up with like 21 definitions of that paper of fairness, all of which were incompatible with each other. So that's another example where, because we're building these systems, we're having to think ourselves about what does it mean to be fair? We value that, obviously. We care about that. But okay, can we properly define it? And in fact, I remember you and I were talking about this. I remember going to a symposium with a bunch of computer scientists and social scientists. And what was fascinating to me was hearing how essentially most of what we in human society think of as fair are really just proxies for fairness, if you like. We say, well, this was fair if it went through this process.
Right.
Right. Jury trials are a classic example. We kind of all have kind of, agreed, we'll accept the outcomes of a jury trial because it's gone through that. Each side got to argue its side, and whatever the jury decides, we'll take that as fair. Is it really fair? Is the outcome really fair? Don't know. But we accept the process as a proxy for that. Sometimes we'll say, well, why don't we take the composition of a group as a proxy for fairness? So if that group of people there decided something, we'll assume it's fair. If they're all white men, we don't think it's fair. But okay, if they're diverse, then whatever they decided must be fair, right? In both cases, we haven't actually defined a fair outcome. We have a proxy for it. So what I think is happening here is that a lot of these systems are now forcing us to rethink these questions about what really do we mean by being fair? What do we really mean by being a human being? When in fact, either in the case of being human, these systems can do that. In the case of notions like fairness and so forth, we now have to build them into these systems. I think those are very profound questions for us as humanity. And I think they're much harder questions in some regards. I mean, the favorite one right now, as you know, is we're now saying, well, is a machine really thinking or not? Well, I don't know. If you're going to argue on the basis of the output, well, the behavior, sure, it may be all algorithmic and probabilistic inside, but if the behavior looks like it's thinking, I don't know. So we may then end up deciding, well, what we count as thinking is if somebody or a system is doing it exactly the way we would do it. So this is the kind of idea of are we looking for behavioral equivalence or substrate equivalence? Behavioral equivalence means it behaves the way a human does, even though it's doing it differently. Whereas substrate equivalence is, well, it has to be doing it the way I'm doing it. It has to be made up of the same stuff that I'm made up of. Otherwise, unless it's made up of the same stuff, I'll say it's not thinking because it's not doing it the way I would do it.
Right.
So I think these are very profound, hard questions, I think.
Yeah, and they're very they're tricky because they're not only logical, but they're also pretty deeply tied to our beliefs and our feelings and how we feel about our communities and our religions and all these things. It's very.
I was going to throw it back at you. So, what do you think? I mean, do you think these systems are intelligent? Do you think these systems are thinking? How do you think about it?
Well, I think there was this. I just recently reread it. There's this great short story by Ted Chiang, Exhalation. It's obviously a compilation. The particular one on exhalation is quite good. It sort of describes this, some form of alien robots, and it's sort of they go through this discovery process where they realize that their existence is not their sort of existence and consciousness. They thought at one point that it was sort of like these sort of markings on metal in their brains, but actually they realized that it was their existence is purely the sort of like pattern of air flowing through their body. And it was the reason I think it's interesting, and this guides me towards this sort of belief that I think that these systems are thinking, and they're sort of like they exist, and there's and there's real intelligence to them, is that when you get these interesting emergent behaviors out of these physical patterns, what's happening is like a pattern of electrons through circuits, and that's sort of like the physical property of what's happening, and the systems sort of like read what's going on in these physical patterns, and you get these intelligent responses,
right.
Just in the same way that from it's not clear if you would call an amoeba intelligent, but you get sort of intelligent responses. You get
right.
things that are like at minimum, enable its survival and sort of enable it to do sort of relatively complex maneuvers. It can surround other organisms, and it can consume them and all this
right.
stuff. And so I think it's not clear where you draw the line between this and, let's say, consciousness, or let's say
right.
all these other more complex ideas that are more loaded. But I think they are thinking, and they exist, and they're intelligent. But these are very deep, interesting questions.
Well, I think in that example, at least, I think we can agree that the behavior is intelligent.
Yes.
What's going on underneath, I think, different people can have a reasonable debate about that, but the behavior seems intelligent.
Yes.
Is what you'd attribute, you'd correspond with intelligence. But I think, the thing, at least for me, that with all these questions is, I think it's quite easy to get, these are very interesting philosophical questions, of course. They're questions of humanity and values and all of those things. I think in some ways I would even go so far as to say they're even tied to even democratic values at some level, because I think democratic values in the sense that I think we have to all be in conversations about these things and be thinking together about these things in a very kind of democratic, kind of principled way. But I do think, though, at a practical level, I'm just particularly excited about how useful these systems are, actually.
Right.
To people and users.
Totally.
And, one of the things that's actually on my mind is, one of the amazing things that these large language models now do is just where they've taken the ability to do translations.
Exactly.
For a while, everybody's looking, well, we should be able to translate 100 languages, but there's no reason why we can't go to 1,000 or more. I'm just fascinated by the fact that for the first time, we can now, train a model in one of the dominant languages, English and others, and then by only showing it a little bit of languages that are so-called low-resource languages. So these are languages where, a lot of people speak them, but there aren't many data resources available online to train the algorithm. But now you can just show them a little bit of the low-resource language. Now all of a sudden you can do translations. One of our teams at Google just did this with Bengali, for example,
wow.
Which is spoken by a lot of people, but it's, again, one of these low-resource languages. They did the same thing with Luganda. Luganda is a language spoken in East Africa by a lot of people, but again, it's a low-resource language. But you train it in one language and show it a little bit of Luganda, all of a sudden it can do translations in Luganda. So I just think the utility and the usefulness of these systems to everyday activities in life is just extraordinary. I think about
Totally.
Some of the what you're enabling, when people can annotate images and be able to understand images and be able to understand what's going on. That's extraordinarily useful.
Yeah. Well, I wanted to close on what I hope will be a fun question for you. Right. So I had the opportunity of meeting your son as well, who is also studying artificial intelligence.
At your old school.
Yeah, at MIT, at our old school. And I wanted to sort of ask, I imagine you two talk about artificial intelligence and sort of talk about some of these topics all the time. How do you notice that the ways that you think about the technology differ from the ways that he thinks about the technology?
Oh, that's interesting. So first of all, he's, unlike me, he's double majoring in computer science and philosophy. So he's already interested in these intersection of these questions. And I think he's different because, first of all, he programs differently the way I learned how to program. I learned how to program in C and so forth, but he does mostly scripting languages, so he thinks differently about those. I think he also thinks differently about what's possible. I'm just amazed every day that we can do what we can do now. He's less impressed by that because he's grown up at a time when AI and machine learning can do this extraordinary thing. So he just thinks he and his generation can do, and you're doing it, right? You got to do even more. So his scale of ambition, and I think the kinds of things that he thinks possible are extraordinary. And I think he thinks differently and more expansively, I think, about applications than I do. And quite often, I get interesting ideas from him about how to think about what we should think about, because he lives with it much more than I do. I think he is different. I think you're different. I think your generation is doing, is more ambitious, think at things in a much larger and quite frankly useful way. And I think he's also grown up in a democratic kind of, context in which these questions of fairness and equality are very important. They're very much on his mind. In some ways, perhaps even more than they are on my mind, actually. So I think it's all good. I think it's, you and all of you and are going to do amazing things. I think it'll be better.
I think it's a great spot to close it. I think there's a lot of reason for great optimism that, all of these topics that we discussed today, there are smart people like your son who are going to think about them deeply and will make great progress over the next decades.
Yeah, but again, to be fair, I'm just very impressed by what you've done, the company you've built, and quite frankly, I'm just curious to see where this all goes next.
All right, I appreciate that so much. Well, I'm excited to. I'm very grateful and thankful for all of the incredible work that you do in obviously not only helping to build this incredible technology, but helping to ensure that we're thoughtful about it and that policymakers are thoughtful about it, and that as a world we're shepherding the technology in the right way. And so I think everyone in the world has a lot to be thankful to you for.
Well, no, thank you, and thanks for having me.
It's been a blast.
Thank you.